Welcome students to another in our Investigating Science series. Today we're in grade 8 looking at the atom. Now, what can you remember about the atom? You may remember that the atom is the smallest part of matter that can take part in a reaction. You may have also been introduced to the fact that an atom consists of different subatomic particles. Now, if we were to make a model of the atom, what are some of the things that we could consider? So, you may have at home Play-Doh, that's what I have here today, and I have different types of seeds. However, just in case you do not have that, what else could we use to represent the atom? You're probably thinking of getting wires, yes, to represent. What would the wires represent? The wires could represent the shells. Remember, in an atom, we have 3 types of particles, right? There is a central portion that is called that's called the nucleus. And in the nucleus, we would find which subatomic particles. In the nucleus, we would find our protons and our neutrons. So our nucleus is in the center, and orbiting the nucleus in different energy levels, and at the secondary level, for CSEC, for instance, we would represent that by using shells. Right? And in those shells, or in those energy levels orbiting the nucleus, we would find our electrons. Now, of course, you can tell me what the differences are between protons, neutrons, and electrons. But for now, we want to represent what we know about the atom in a model. So, what should I do? So definitely, I need my 3 subatomic particles. So I have, this is, I think they call it chickpeas. We also have split peas. Sometimes you may see them as green. This one is brown. And we have our own regular red peas. So we have 3 types of seeds or beans, if you want to use that term, that we're going to use to represent our subatomic particles. Get a styrofoam plate or some other flat surface, right, that is circular, that we're going to use to construct our atom, our model of our atom. All right? Now, of course, we have 2 different types of Play-Doh, different colors, all right? And we're going to use this to construct the model of our atom. So what do we need first? What is required in a model of the atom? We would need a nucleus. Remember we said the nucleus is the central portion. So I just take some of this yellow Play-Doh, all right? See if we can get it into a little ball. And of course, we're going to try to flatten it as much as possible into that shape of the central portion. And we will call this our nucleus. So in the model of the atom, we have a central portion, which is the nucleus. Now, what would be around the nucleus? So earlier we said around the nucleus, we would have different energy levels represented by shells at your level when you take on this subject. So we want to create our shells. Alright, now depending on the element that we're dealing with, depending on the atom on our periodic table, we note that the number of shells may differ. So of course yours may be a little more fashionable than mine. As I said, you could use strings, wires, you name it. You can be creative with this. So we have our first shell, and then we're going to try to create another shell. Alright, we can do this. Of course, what else could we use at home? If you think of making dumplings, you could use the flour. So if you don't have Play-Doh, use the flour. Of course, you have to ask mommy or daddy. Use the flour and make these long dumplings and use them as your shells. Good? So that's an idea of another way that we could try to create our model. Now we want this to be close to as circular as possible. Alright. So we have 2 shells and our nucleus. Alright? And of course, if you had time, you can create a 3rd shell. So, again, we're looking at the model of the atom. So what would we place in our nucleus? So remember, we said in our nucleus, we have protons and neutrons. So I'm going to put some protons and neutrons, and you're going to try to determine which element could we be representing. So I have 3 red pea seeds. I'm going to call these my protons. So I have 3 seeds. Look, you see I'm putting 3 red pea seeds. So this would represent my protons. I have 3 protons in this particular atom. And I'm going to add 4 chickpeas, and this would represent my neutrons. So think about it. What atom has 3 protons and 4 neutrons? I'll give you some time to think about it. So that is what is in my nucleus. Now if I have 3 protons and 4 neutrons in this atom, how many electrons do I need orbiting the nucleus? So my split peas will represent my electrons. And notice in this case, my split peas, they're much finer, right? And you would know that based on relative mass, right, the mass of the electron is very negligible. So it really doesn't contribute much to the mass of the atom. Whereas the protons and the neutrons have a much greater mass, relative mass. Okay, so if we have 3 protons in our nucleus, how many electrons can we have orbiting the nucleus? That's correct. We can only have 3 electrons in this particular case if we're talking about a neutral atom, because in a neutral atom, the number of electrons and protons would be equal. And why is that so? If it is neutral, protons having a positive charge must cancel out electrons having a negative charge. So we need 3 electrons. How do we place these on our shells? So if I have 3 electrons, I'm taking out my 3 electrons. How do I place them on the shell? Do I put all 3 on the first shell? No, we don't, because in chemistry, there is a rule as to how we place electrons. So the first shell can hold 2 electrons. So I place 1, 2 electrons on my first shell. And then I have 1 electron left. And of course, that can only go on my second shell. So based on this representation, what element, what atom would this represent? I have 3 protons, 4 neutrons, and I have 3 electrons on my shells. Look at your periodic table and try to find the atom with the atomic number 3. That atom, that element, would be lithium. Now suppose I've added some more electrons. Let's see if we are thinking here. So I'm going to add another proton, that's 4. Matter of fact, let me add 2 more. So I'm adding some protons. So I now have 6 protons. And I'm adding 2 more neutrons. Yes? So we have 6 protons and 6 neutrons. So it means we need how many electrons in our shells? We need 6 electrons. So 6 electrons, we already have 2 on the first shell. We have 1 in this shell, so we need to get 3 more. So again, we have 2 on the first shell, 4 on the second shell. And what we're doing here is looking at the electronic configuration of the atom. So which atom, look in your book, look on your periodic table, has 6 protons and 6 neutrons and 6 electrons in their shells. If you look, that atom would be carbon. And from this, we can work out the electronic configuration, because carbon would now have 2 electrons on the first shell and 4 electrons on the second shell. This is something that I know you can do at home. Get your different materials. Remember, you can get pieces of wire. You can use flour to make your shells, right? Get different seeds or other materials that can be used to represent your subatomic particles, and make these models of the atom so you can understand the whole concept of atomic structure. That's all the time we have for today. Work on those models so you can better understand how the atom operates. Until next time, see you again on Investigating Science.